So this is the second meetup in the series Platform Builders. The next one will be with the topic performance, right? Yeah. So the topic of the first session today is on Redux. My name is Leeor Aharon. I'm a front-end engineer at Wix. Spend my days building stuff with Redux, React, bunch of other frameworks. Just to tell you a bit about myself, I've been in the software business for the last 20 years this year, since '98, basically my first programming job. Had the pleasure of working with networking, security, backend, cloud, lots of stuff. And for the past year or so, I've been doing front-end at Wix. And specifically, we're here to talk just about front-end, so we can forget about the rest. To talk about Redux and give you some brief introduction, or maybe not so brief introduction into what Redux is, I'll start with the problem. I'll show you what Redux is, which is pretty simple. And then we'll try to dive into the more complex issues that you'll need to face when using a library like Redux. So first of all, what's the problem? What is it that Redux is trying to solve for us? What is it helping with? So the core of the problem is mutation and asynchronicity. That's a mouthful. Basically, it means that we have the application state is constantly changing, and the application itself is asynchronous. So we end up with many threads of operation, let's say, promises, async operations that are in the background working, and each of them at any point in time can change our state. And the state is spread out across the whole application. If we're talking about a React application that doesn't use Redux, for example, then each component can have its own state. And each component state is constantly changing in a manner that's completely independent of any other component. So how do you know what state your application is in? And front-end applications are constantly getting more and more complex. We're talking about single-page applications, applications that start from something that was rendered on the server, applications that are the single point of truth for what they're for the services that they manage, and they need to synchronize that state to the server. We have applications that need to prefetch data to provide better performance. Each of these little features, each of these little additional pieces of code that we add state to our application. And that's before we rendered anything to the screen, because then we need to handle pagination, we need to handle what elements are shown, what's not shown, what's still loading, and we have a spinner showing up. So the applications keep getting more and more complex. And throwing synchronicity into all that mix makes it very hard for us as humans to rationalize what's going on within our app and what state our app is in. So this is what Redux is here to help us with. So let's see how it accomplishes it. Redux describes itself as a predictable state container. What it means is that it will hold the state for you. Your state is no longer spread out across the whole application in little bits and pieces, in different components, in different files, in different modules. There's a single place that holds your whole state. That's Redux. That's the Redux store. And the way it behaves lets you write an application that can behave consistently, because there's only one state object, And it's easy to test. We'll see in a bit. We'll understand why. Certain behaviors and ways to code your application are enforced, or not exactly enforced, but as you're guided towards using, and then you get an application that is easy to test. And eventually, Redux itself can run in different environments. It can run in the client. It can run in a server. You can run it on a Node backend service. You can run it in native apps. So you can put it anywhere, and then, again, you have a single state management core that you can reuse in different places when you need to port your app. Redux follows three core principles. These are the principles. It's, as I said before, it's the single source of truth for the whole application. This is your whole state. It all starts here. Okay? State is read-only. No longer, gone are the days where any single component can just change some flag, increment a counter, delete something from the state, push something into an array. No, that's gone. You cannot do that anymore. State is immutable. It's read-only. No one touches it, except for reading. You want to change the state, that's fine. You should eventually change the state. You do that with something that's called pure functions, which basically gets the state, gets some sort of descriptor that tries to describe what happened, and then the state changes. Anyone who wants to know what the state is can go to the first principle, the single source of truth, and see what the state right now is. There will not be a lot of code in this presentation. I will spare you that, but there's some code just so you know what Redux looks like. So you usually split the code into three files. Again, three files. The first will name the different actions that your application can handle. For example, if we're talking about a simple counter application, you're able to increase that counter and decrease that counter. Simple enough. Then we have, it's common practice to have action creators. Action creators are little functions that create objects that describe the actions. So if we have action names like increase counter, we have an increase function that returns an object with a type property that says increase counter. That's it. Sometimes there are actions that are more complex and have data of their own, that some payload that they need to provide so that whatever function eventually changes the state knows exactly how to change the state, some additional information. In this case, there's no need. So action creators. And then we have something called a reducer. Strange name. Let's ignore the name for now. What it does is get the current state. It gets the action that was just now sent to Redux, given to Redux. And then it decides what needs to be done. How does the state change? What transition needs to be performed when this is the action and this is the state. Notice that it doesn't mutate the state either. It creates a new state, a new copy of the state, only changing what's needed, either increasing or decreasing the counter. So any component, any piece of code that saved pointed to the state will not know that the state changed. It still sees the previous object. And down here you can see we have something called a selector. Basically, you give it the state and it gives you back some piece of the state. For example, in this case, we have our whole state is a counter. We give it the state, it gives us the counter property from that state. So if we have, if we send a dispatch, it's called sending an action to the store is called dispatch. If we send an increase action to the store, we'll get here to this reducer. It will get the current state. The current state might be that the counter value is 4. Gets an action that says increase the counter, and then it will go to the right switch and increase the counter by 1. Return a new state. That's it. We're done. We have a new state that says counter 5. And this is what it looks like for the app to actually make the change. Once that function, the dispatch function, returns, you have a new state. If you go to Redux and ask it, give me the state, you'll see that the state is now 5. That's it. This is Redux. It's pretty simple, right? You define actions. You define how the state transitions from one state to another, given any action that can be sent to it. And you get a new action, and you get a new state. And then do with it what you need. You have the state. It's a single source of truth. You have everything there. You can have, in Redux, it's common practice to break the state down into multiple components. One of the strongest points of Redux is that everything changes as a whole. You dispatch an action. Redux calls each of the reducers, each of the functions that changes the state, builds a complete state object, given anything that has changed, and you get back one single state object again, with all the changes that have happened to the state, all the transitions. So it's not broken down. There's a clear-cut transition between one state to another when an action is dispatched, and that's very important. Some of the advantages you get is that you have consistent, and your state logic is in one place. That reducer that we saw handles all state transitions. It knows the state, it knows the business logic, it knows what needs to be done to the state each time each type of action is sent. So you're pretty dry. You don't repeat yourself across different parts of the code over and over again. And it's easy to start working on a project, read the reducer, and understand what the business logic is, because it's all right there. State changes, as we saw, are driven by simple objects called actions. And that's pretty important as well, because these simple objects can be serialized. You can send them and synchronize them across different clients if you need to collaborate, to write an application that implements collaboration, for example. You can synchronize them to the server and keep another copy of the state on the server if you need to duplicate your state. That's one way of achieving state synchronization when you need to make sure that you have a single source of truth. And you have another advantage in which you keep your whole business logic within the Redux state store, and then it's completely decoupled from your display, from the view. The view, while it's showing eventually data that's in the store, is not tightly coupled anymore, and you can use different selectors and functions that operate on the state store to generate what needs to be viewed. And then if you need to refactor the business logic, if you need to change the way things are shown, there's a decoupling that helps you deal only with what you need. But it does have its own trade-offs. There's boilerplate. As you saw, all we had was a simple counter that we can increment and decrement, and then we had a separate file with the action names, another file with the action creators, then we had a file for the reducer, which has its own boilerplate. It's a switch case. Then we have selectors for accessing different parts of the state. Each and every time we need to write a simple feature, we're going to have to touch many parts of our code. And sometimes that's too much. Sometimes you can feel that there's too much boilerplate for what you're trying to do. And it's opinionated because it says there's only just a minute. It says that there's only a single source of truth. That's itself. It's immutable. And you need to use pure functions to change the state. Were there any questions? OK. So now that we basically have some sort of understanding what Redux is, it's a predictable state container. It's easy to predict how state will change given an action because the whole code is there in the reducer, and it's easy to read and understand and reason about. And we know the different parts of what Redux is. We have actions, we have reducers, we have the state store. Let's see what we put into Redux, what we put into that state object. So I briefly mentioned it earlier. We usually break the state down into multiple objects. We try to break the state down into objects that describe business logic, business knowledge. By breaking the state down into meaningful business logic units, we're able to keep the code clearer because each of these components has its own reducer, its own actions. And it's easier to understand what that component does. It's in a large application, you'll have multiple components, each of them dealing with a single part of the application's business logic. And then each of those will have its own reducer code that tells basically the story of how that state changes, what transitions are available, what kind of actions can be performed on the state, and how will they affect the state. We'll touch into that a bit later again. Then within each of these parts, we need to organize the data itself, the actual data that we're storing. So we took the whole application, we broke it down into multiple parts, each part dealing with its own part of the business domain. And then it still has its own data that it needs to keep. So many times, front-end applications need to be able to pull data from remote services. It can be some RESTful API endpoint. It can be your own backend with some specific protocol that you pull data from. And again, often you'll find yourself dealing with objects that where the schema is very deep. You have entities that contain additional entities, and many times this state tree is recursive. And I'll try to explain show what I mean right here. Let's say we have a blog, some kind of application where you can write posts and people can comment on your posts, like a forum, for example. So what would your data be? You'll have the posts, right? It's an array of different posts that people have written. For each post, you'll have the title. You'll have the content of that post. But you'll also have the author. You're going to have some sort of object that describes who wrote that post. And then people can comment. So you have an array of comments. Comments have content and have authors. So now we have the author object appear in different parts of the state. And these can be the author. If we get this from the server, the same author can be. We can find him in different posts and comments over and over again. It's wasteful. And trying to map that into a view is going to be harder. And dealing with that in the long run is going to be harder as well because it's a deeply nested state object. So I call that normalizing data. This data is not normalized at all. What does normalizing data means? What does it mean? It means that we want to flatten it out and we want to break it down into the different elements. So the different entities, each entity gets its own store, let's say. We have one for the posts. You can see that we have the first property is post, and it contains a mapping of post from ID to post. And then within that, you'll see author identified by an ID. And in comments, you'll see each comment identified as an ID. Comments as well are a mapping between IDs and comment objects. And then the author is an ID. And of course, we have the authors identified by IDs. This kind of method to store data is easier to work with. It does have its own trade-off, of course, like anything. It means that you need to manage these IDs, or you need someone to do it for you. If you can read from a backend service with IDs, great, someone else's problem. But if not, you're going to have to do it yourself. And after we've looked at our application, understood what the state needs to hold, and decided how we want to hold it, what components we break it down into, how the data in each component is held. We need to understand whether there's anything that we don't want inside the store. I mean, if we're an application that works with A/B testing, do we need the A/B test information within the Redux store? If we do put it in the store, it's going to be less convenient to access that data from other parts of the state that needs to know which tests are running and what the definitions are. To kind of sum up what we talked about so far, some rules of thumb. Break the state down, as I said, into meaningful elements. It will help you understand later what each element is doing, how it's doing it, and why it's doing it. It will also help you reuse that element in other applications if you ever need to. Normalize your data because it will make it easier to manage that data and access it and view it. And go with the principle of single source of truth. Regarding that last slide, if you're just starting to use Redux and you come to the question of whether to put something in the store or not, put it in the store. Further down the line, if you decide that you've made a mistake and it should be removed from the store, remove it. But start with it in that store. It's usually more convenient. It's more understandable when you read a Redux application and you just find everything in the store than some sort of data that passes through closures and through other means. It will also help you debug your application because when you go and look at the state, you'll see everything there in one place. A/B tests, canonical data that you read from the store just for cold start. Everything you need will be there, and that's very, very powerful. So use it. Start with that. Then if you see a reason not to, remove things from the store. In the Redux realm, there's something called side effects. And side effects are anything that happens basically as a result of changing your state that isn't in the functional programming world. We call it that isn't pure. It's basically, you have your state, you dispatch an action, the state changed, now something needs to happen. It's very nice to change the state, and it's very nice that the view has changed and the user sees something else, but the user had some sort of reason to do something with your UI. He was meaning to do something. For example, maybe you're writing some cloud management console, and then the user wants to spin up a machine, a VM. He clicks the button, an action is sent to the store, the state changes, says, hey, there's a machine here, but does it make it so? The machine isn't there yet. Someone needs to actually spin up that virtual machine. Making that happen is what we call side effect. It sounds negligible, but why the application is there in the first place, right? So if we leave side effects out of it, we see this kind of loop that we have. Actions, through reducers, modify the state, view renders, and there are additional user interactions. That's kind of a lie, because the way this happens is a side effect. Updating the view is a side effect of changing the state. So anything that happens as a result is a side effect. And when you want to change the state, we've seen earlier, the state changes immediately. Changing other parts of the world within the application or outside the application takes time, which brings us back to asynchronicity. We start processes that take time while the user keeps working. The state will keep changing. New side effects will be fired, will be started. And we need to be able to make sense of everything. So Redux has some built-in support for subscribing to notifications about actions being sent to the store and processed. It doesn't let you know, it's sometimes a misconception, it doesn't let you know when the state changed. It lets you know when an action has been dispatched. And it's a very subtle but important difference to understand. If you dispatch an action that doesn't change the state, that mechanism will still be fired. Any listeners that you have that are listening in on the store will be called and will try to process and find whether anything has changed. Likely, they're going to look at the new state and try to understand whether something has changed. So it's going to be, processing-wise, it's a big operation. This is what it looks like. You give Redux a function. It's called a listener. And it's just called with no arguments. It can do whatever it wants. Usually, it will get the state and then do something with that state. In the case of React, React is a listener to the Redux store. And when it's called, it gets the new state and updates the DOM where needed, if needed, and basically re-renders the application. I'll try to briefly run through some example just to get the notion of what's working with the Redux listener feels like. If we have our counter application and we want to synchronize that, sync that counter to a backend server, then we'll create this. We can create this listener, give it the store so it can get the state, give it an API object which lets it fire some API calls to the backend server, and whenever it's called, it just gets the state, calls the selector with the state object, gets the counter value, and sends it to the backend. Easy, right? But remember that we said this function will get called every time an action has been dispatched, no matter what has changed. So it's going to be noisy. It's going to be sending a lot of API calls to the backend service. We can optimize it by keeping the last counter value that we saw ourselves, put it in some variable, and then test whether it has changed. If it does, we'll send an update. Less noisy, but susceptible to asynchronicity. because it communicates with the server. There's network latency. Packets get lost. Connections can reach the end server out of order, and then you're not so sure what the backend value is. So one last tweak, we can add the date to the set counter, and we're pretty covered, I guess. So this is the default that you get when you get Redux. Is it enough? You saw that you have to do a lot of management on your own to make sure that you're able to deal with many of the issues that being called whenever an action is dispatched, being called when the specific part of the store that has changed, that was changed, is not some part of the store that you're interested in. There are many things that you need to be able to deal with. So what are we looking for when we're looking for a solution to how we should write our side effects, how we should manage our side effects? So we said earlier that one of the strengths of Redux is that it gives us the ability to take our whole business logic and put it in one place. We want to keep that. We don't want to break it down again and spread it across our application. We want to be able to write reusable components. Sometimes components have their own actions and their own side effects. And when that happens, we need to make sure that these side effects can be, the whole component together with the side effects can be reused whenever it's inserted into another application and used in another application. And Redux does provide us with a mechanism that allows us to expand the basics that it provides us. It's called middleware. Middleware is a generic name for plugins that are able to extend the functionality and behavior of Redux. They do so by changing the way the dispatch function works. Basically, if you create a vanilla Redux store, you get a dispatch function that goes directly to the reducer. Changes the states, changes the state, comes back, you're done. If you add a middleware, then you first get to that middleware. That middleware gets to do whatever it wants, like nothing, dropping your action and ignoring it, and only if it deems it, worthy of getting to the actual dispatch function, it will pass it to the actual dispatch function for the reducer to be called and change the state with it. It looks something like this. Excuse my poor graphic skills, but basically, if we have our reducer, middleware kind of wraps around Redux and the reducer, and whenever we try to dispatch actions, they are first intercepted by the middleware and only then passed to the reducer. I think one of the most common players in this field of side effects in Redux is what's called Redux Thunk. It was written by the same guy who wrote Redux, Dan Abramov. It's a very, very simple middleware. It weighs 217 bytes, minified and gzipped. That's it. It's really small. It's easy to understand. That's a huge plus. It lets you dispatch functions instead of actions. It's pretty simple, right? You dispatch an action, a function. That function is called within the context of the Redux store. What does it mean? It will get the store object, so it's able to dispatch additional functions and read the state. Okay? This is kind of my attempt at visualizing what happens. You can dispatch a thunk. The middleware will execute that thunk. That's a bunch of imperative code just running through, doing stuff. and it's able to dispatch additional actions and functions, thunks, to the store. This is a very simple visualization of what might happen, but consider that this thunk can dispatch additional thunks. User code, or your code, can dispatch additional thunks. Thunks can be asynchronous. That means that we're back into asynchronicity and mutation, because each of these is working in separately, concurrently, and each of them can now dispatch actions to the store. The whole store will transition as a whole, but still you can have any number of thunks working concurrently, firing actions to the store and changing the store. The main pro of Thunk is that it's very simple. This is the whole middleware. Okay? This is the whole thing. It's like the main part is 8 or 9 lines of code. So it's really simple to understand. If you need to use something that is simple to understand, it's also simple to use. It's simple to reason about. When something breaks, you understand what's gone wrong. But it doesn't come without its disadvantages. So many times when you use Thunk for a long time, and it's easy to reuse Thunk. You end up finding yourself writing Thunks when you should have been writing reducer code. I did come across code that was written, and I've probably written that myself as well, that instead of writing the transition or the logic within the reducer, it was written in a Thunk. And that's really a shame, because we've now gone back to fragmentation, to business logic fragmentation. And we have implicit state within functions instead of within the state store and within the reducer. And if we remember asynchronous thunks, as I mentioned, and multiple asynchronous thunks running around changing the state, then we're back into mutation and asynchronicity. It's also usually, mostly, not dry, because you end up with multiple thunks doing parts of the same logic and then repeating themselves over and over again, and then you need to refactor something and you change a thunk, forget to change a bunch of other thunks, and you have bugs. So this is Thunk. Rule of thumb, if you're just starting out with Redux, choose Thunk. Yes, it does have the disadvantages of what I said, but it's so simple. Start with that. Later, when your application outgrows Thunks, and you will know when that happens, choose something else. But by then, you'll have a better understanding of what Redux is, how Redux works, how you want to be working with Redux, and what you'll be feeling comfortable with at that time. So start with Redux. Start with Thunk, Redux as well. Start with Redux and Thunks, and then see where you want to go to. And just a couple of options of where you can go to are Saga, Redux Saga. It's one of the bigger cannons that you can throw at Redux, at a Redux application for solving the problem. It weighs 8.5 kilobytes minified and gzip. It's really big compared to Thunk, right? And it describes itself as a separate thread in your application, solely responsible for side effects. Visualization again. This is kind of what it looks like. You dispatch actions. Those actions will reach the reducer. But then you have multiple pieces of code that can listen for actions that were dispatched to the store and start executing code. And while they execute code, they are able to communicate with the Saga middleware. And there's a whole API for what happens here. It's not. It's a bold error for a reason. The API reference for Saga describes Saga helpers, 28 different effect creators. You have effect combinators. You have interfaces, and you have utilities, and that's just for managing side effects. It's a very big library. It can do a lot, but it's complicated. You can see here just briefly that all Saga functions are generator functions. There's yield all over the place, and you keep communicating with everything you do is computing back and forth with the Saga middleware. So the advantages is that it's a very flexible library. You can probably do pretty much anything with this library. It's well documented. There are a lot of examples. And testing, it's easy to test because what the sagas that you write are pure, and it's easy to unit test them and to know that they're doing exactly what you want them to be doing. But it's complex, and there's a learning curve to be able to work with it well. The last one that I'll talk about is called Loop, Redux Loop. It's a part of the Elm architecture. For those who don't know what the Elm architecture is, I strongly recommend reading what the Elm architecture is, because it will help you understand what Redux is and how to work with Redux and the whole approach that Redux has implemented. So it allows you to sequence your effects by returning them from the reducers. What it means is that reducers no longer react to actions that have been dispatched to the store. They also decide what gets to happen next. So there is a plus here where your business logic is now really in a single place. The reducer both understands how to transition the state and what the next actions that need to be taken are. It looks a bit like this. You dispatch an action to the loop middleware. The loop middleware will decide what gets sent to the reducer. In the meantime, in a separate kind of thread, let's say, it fires effects. When that effect finishes, it fires another action to the store so that your reducer knows whether that effect has succeeded or failed. And then you can act on it and do additional processing and change the state and fire additional actions. And also, reducers, pure, it's easy to test. The main disadvantage is that you can't write a single component as part of an application with loop. It's not, the way it bores into Redux, let's say, is much more complicated than middleware. So you need to use loop in your whole application, or at the very least something called combined reducers, the combined reducers that comes with loop. Just before we finish, a quote that the guy who wrote Redux in the first place said or wrote. You might not need Redux. It's very important to remember that you need to use Redux when you can and should. The three principles of Redux can be used anywhere. They are single point of truth, immutability, and pure functions for changing the state. You can do that anywhere. You don't need Redux for that. So use Redux when it makes sense to use Redux, when the trade-offs make sense. You don't mind the boilerplate. You don't mind how opinionated it is, because what you get from it is worth it. So that's the right time to use Redux. If there's anything that it's important for me that you remember from this presentation, is that Redux is a really good tool to build stable, consistent applications. So I really recommend using it. If it's the first time you're starting out with Redux, as I said earlier, put everything in the store. break it down into meaningful components, put everything in there. Just being able to read and comprehend those parts of the store will make your lives much easier. Use Thunks. They're really simple. Change later when you understand better what Redux is and how it works. And I think that's it. Just think about how you're doing things within the Redux, your Redux application. That's it. Thank you very much.